Tides are the rising and falling of Earth's ocean surface caused by the tidal force of the moon and the sun acting on the oceans. As you can see from the picture, from the left is the low tide and right is the high tide. Principle of the tidal energy. Tidal energy is the result of interaction of the gravitational pull of the moon on the seas. Schemes that use tidal energy rely on twice daily tide and the resultant upstream flow and downstream ebbs in estuaries and the lower reach of the same river. In the traditional tidal mills, a small pond or pool is simply topped up close a high tide, and then at low tide the trapped water is used to drive water wheel. In modern system, the water carried upstream by the tidal flow is trapped behind a barrage. The incoming tide is allowed to pass through sluices, which are then closed at high tide, trapping the water. As the tide ebbs, the water level on the downstream side of the barrage reduces and a head of the water develops across the barrage. The head is used to drive the water through turbine generator.
The tidal barrage built across suitable estuaries are designed to extract energy from the rise and fall of the tide using turbines located in water passages in the barrage. The potential energy due to the difference in water level across the barrage is converted into kinetic energy in the form of force, moving water passing through the turbines. This in turn is converted into rotational kinetic, then driving a generator to produce electric. Gates and lock. Tidal power basins have to fill and emptied. Gates are opened regularly and frequently, but heads are vary in highest and on the site where they occur, which is not the case with the conventional river projects. The gate must be opened and closed rapidly, and this operation should use a powerhouse. Because small head available large size turbine and hence powerhouse is also large structure. Both the French and Soviet operating use the bulb type of turbine and propeller type with the reversible blade.
The bulb group. A bulb-type turbine is example of flow turbine. The bulb set resembling in appearance a small submarine is made up of an ague-shaped steel contains a horizontal duct in which alternator and a cabin turbine is placed and entirely surrounded by water. Rim-type turbine. Different types of turbine are under study. Usually mentioned are include shaft turbine, ring-type turbine, or straight flow turbine where the gear is attached on the turbine blade arrangement that couple two turbines of conventional type to one generator and a hydraulic system in which six turbines are to hydrostatic pump. The main problem in the ring-type turbine in which the rotor surrounds the turbine, the runner, and the rim. Advantages: once you build it, tidal power is free. It produces no greenhouse gases or other waste. It needs no fuel. It produces electricity reliably. Not expensive to maintain. Tides are totally predictable. Offshore turbine and vertical axis turbine are not ruinously expensive to build and do not have a large environmental impact.
Limitation. Cost of construction of a tidal power plant is high. The achieved generation is for a short period of time. This transmission is expensive and difficult. Influence aquatic life adversely and can disrupt migration of a fish. Advantage of wave energy: renewable, environmental friendly, abundant and widely available, variety of way to harness, easily practicable, less dependency on foreign oil gas, no damage to land. Disadvantage of wave energy: suitable to certain location, effect on marine ecosystem, source of disturbance for private and commercial vessels. Wavelength: weak performance in drought weather, noise and visual pollution.